All right, so in this example, we're going to solve this system of linear equations. Now, we're going to use an inverse matrix, as it states here, to do this. We can see the coefficients here. We've got -1, +6, -2. That's going to be the first row of our matrix that we're going to construct now. So when we're solving this system, we need to rewrite the question as a product of matrices, essentially. So the first row, let's just draw our matrix. So it's going to be -1, 6, -2 for the first row. And then if we look at the coefficients of the second row, we've got +6, -2, and -1 again. So we're going to write our second row. So it's going to be 6, okay, -2, and -1. And the final row, I won't highlight it, but we've got -2, 3, and 5. So that's going to be our matrix. We'll call this matrix A. All right. Now, in order to state the problem, we need to multiply our matrix A by a 3x1 column vector, essentially, or sorry, a 3x1 matrix, which is a column vector. So this is going to have the variables X, Y, and Z. And as you can see, when we carry out the matrix multiplication, which will reconstruct this problem that we have up here, we've got the first row multiplied by the first column. That will give us -x plus 6y subtract 2z, just as it stipulates in the question. And then all this is going to be equal to another column vector, or a 3x1 matrix, which has the values 21, -16, and 24. All right. So this is the question restated, and we're finding the values of X, Y, and Z in this question. So our first task, now we've restated the problem, is we need to figure out the inverse of the matrix A. We're going to do that in stages. This is a 3x3 matrix, so some of the work is a little bit involved. So if we do it step by step, it shouldn't be too much of a problem to get to that inverse matrix. So let's start off with step 1. I'm going to use some of the space up here to do this. So step 1. Just have to rewrite that. I don't know why it's not working. Step 1. So we're going to find the determinant of A. So we're going to have det A Okay, now the determinant of A, we have to use cofactors and determinants to do this. So we're going to, first of all, eliminate the first row and the first column. So I'm just going to highlight those, and you'll see that what we have left over is the bottom corner. So to get our determinant, the first term of our determinant is going to be -1, which is the first entry in our top row right here. Okay, multiply that by the determinant of what has not been highlighted, so the part that has not been cancelled out by eliminating that first row and that first column. So we're going to multiply that by -2, -1, 3, and 5, and this is the determinant of that 2x2 matrix. So I'm using straight lines here to denote the determinant of the matrix. I'm not using a curved line, which would be the 2x2 matrix itself. All right, so that's the first term. Now the second term, we're going to have 6, I'm just going to leave the sign out for a second, multiplied by the determinant of what we get when we eliminate the middle row. So not the middle row, sorry, the middle column. So I'm just going to move that highlighted passage over, and we're going to work on this number 6 here. So you can see now that we've got negative, sorry, I beg your pardon, 6 multiplied by 5 and subtract -2 multiplied by -1. So we're going to find the determinant of this 2 by 2 matrix. Get my pen ready. So this is going to be 6, -1, -2, and 5. All right. So that's that. Now, the other thing to consider is the cofactors. Now, the cofactors basically tell us that there's going to be a sign change for each of these terms. So it goes like this. The first entry is going to be positive. Okay, that means that we have +1 multiplied by -1, which doesn't change it. The second entry in that top row and middle column is going to be negative. This means that I've got to put a negative sign here, and it alternates like this. So the next one will be positive. So my next one, I'm going to have a +2. And then once again, I'm just going to move this highlighted piece just over slightly. So we can see that this time we're working on the -2, which is going to retain its sign. And then what we've got left over is the determinant of what's not been shaded in that bottom corner. All right, so let's put that in. So it's going to be, sorry, it's not +2, is it? Let me just get rid of that. It's going to be -2. So subtract 2, and then we've got the determinant of 6, -2, -2, and 3, and just close that determinant. So this, once we've evaluated all this, is going to give us the determinant of the matrix A. And this is only the first step. So let's go ahead and compute this. So we're going to have -1 multiplied by, we multiply the leading diagonal together, and then we subtract the product of the non-leading diagonal. So -10 subtract -3 is basically going to be -10 plus 3, which is of course -7. So we'll write that in. All right. Then we've got -6. I'll do this determinant for the middle term. So that's going to give us 30 subtract 2, which is 28, which goes in there. And then we've got subtract 2, and we've got 18 subtract 4, which is of course 14. Okay, let's carry on. So we've got -1 times -7 is +7. 6 times 28 is -168. And subtract 28. And this is going to give us a determinant of -189. So we know, now we've computed the determinant, because this value is non-zero, it's not equal to 0, we know that this is now a non-singular matrix. Okay, so this means that a solution does exist. All right, so now we've done step 1. We've got the determinant of A after a bit of legwork. Now we're going to construct the matrix for the inverse of A. Now, again, we're going to have to do this in steps. It's not straightforward by any means. So step 2, and this is the bit that is probably the most technical, is we're going to have to construct a new 3 by 3 matrix, and we're going to use the determinants of the minors. Now, the minors are the entries that are not eliminated once we select a particular element. So, for example, we'll start off with at the top left corner. So I'm just going to highlight the first row, and I'm going to highlight, sorry, that's the first column, isn't it? I'm going to highlight the first column and the first row. Now, what we do to compute our inverse matrix is we have to find the determinant of what is left over. This is called a minor. So the determinant of what's left over is going to be -2, -1, 3, and 5. Okay. Now that is going to be the top left entry in our inverse matrix, or on the road to our inverse matrix once we've done that. Now we're going to carry on the second entry. So if we're just going to move along where the 6 goes, we're going to have to compute the determinant of what's left over. So this is going to be 6, -1, -2, and 5. And granted, this is what we did earlier when we computed the determinant of A, but we're going to have to do this for every single entry in our matrix. So again, moving on to the third entry, I'm going to move that highlighted part over. We're now going to have to compute the determinant of the minor 6, -2, -2, 3. Okay, so this is going to be the top row of the next stage of our inverse matrix. It's not going to give us the inverse matrix as such, not just yet, but it's one of the steps leading us on the way. For the middle row, I'm going to have to just drop this down. We're going to work on that number 6 in the middle row, the first entry, and we're going to have to compute the determinant of what's left over. So that's going to be 6, -2, 3, and 5. Okay, same way again, we're going to move on to the middle entry. So I'm just going to move this over. Whatever's left over, we have got -1, -2, -2 again, and 5. Okay, and then the final entry, let's move this over again. All right, so we've now got -1, 6, -2, and 3. All right, and then the bottom row, just to finish off. So let's drag this across. So that's on the bottom. We're working on the -2 in that bottom left corner of our matrix. So we've got 6, -2, -2, -1 left over. We're going to compute the determinant of that. Moving into the middle. We're going to compute the determinant of -1, -2, 6, and -1. And the final entry, you'll be glad to hear, is going to be the determinant of -1, 6, 6, and -2. Please take time to check that these are indeed correct. Okay, now this is going to form a matrix in its own right. So we're going to put this into curved brackets, or I'm going to try to, and that's going to be step 2. Now, step 3 is we're going to evaluate these determinants, and then we'll have another 3x3 matrix. So step 3, let's evaluate the determinants. All right, so we'll do these in green. So the first entry, you can check this for yourself. So I'm just going to write them out. We're going to have -7, -28, sorry, just let me check that. No, no, that's not right. Start again. So the first entry, so we've got -10 plus, that's -7. Yes, -7, sorry. Okay, then we're going to have 28. Then we've got 14. Okay, middle row, we've got 30 plus 6, that's 36. -5, subtract 4, so that's going to be -9. Okay, and then we have -3, subtract -12, so -3 plus 12, which is of course 9. And then the bottom row, we have got -6, subtract 4, that's -10. 1, subtract -12, so that's 1 plus 12, which is of course 13. Okay, and then we have 2, subtract 36, which is -34. 4. Again, just take your time with this. If you make an error, don't worry, just go back and change it. Right, now that's step 3. So we've computed our determinants for each of those minors. Now, what we've got to bear in mind now is that there's going to be some sign changes. Now, sign changes occur because of the cofactors. Remember the first row, we have a positive entry here, a negative entry here. So if there is whatever the entry is in that second, in that first row, that second column, we have to multiply that entry by -1, and it alternates. So this is going to be positive. Then in the second row, we're going to start with negative this time, positive and negative. Then in the third row, we're going to start with positive again, negative and positive. So what this does to our step 3 is anything where we have a negative entry, we're going to have to multiply it by -1. So for the first row, the -7 and the 14 remain the same, but we're going to have to multiply our 28 by -1 there. In the second row, we have to multiply our 36 by negative, and we also have to multiply our 9 on the right hand side by a negative, so that's -9. In the bottom row, -10 or -10, sorry, and -34 remain the same, but our 13 in the middle is going to have to be multiplied by -1. Okay, so that concludes step 3. Now moving on to step 4. So slightly unusual step this. We're going to take our step 3 and we're just going to rewrite it. It's an interesting step because we keep the leading diagonal exactly the same as it is in step 3. So I'm just going to highlight that. We're going to maintain -7, -9, and -34 on that leading diagonal, but then the entries on either side of that diagonal are going to swap places. So it's an easy step to do. It's just a strange step in the context of the question. So I'm going to write my leading diagonal out again. So we've got -7, -9, and -34, like so. And then going back to our step 3 that I've just been talking about, this -36 and this 28 are going to swap places. So let's write those in. So this is going to become -28. Let's put that in. And this is going to be -36. All right. Do the same thing for the other entries. So the -10 down in the corner and the 14 are going to swap as well. So let's do that. Let's have another different color. Okay, so we're going to have 14 down here and -10 up in the top. And then finally, we're going to have a swap with the -13 and the -9. All right, let's put those in. So we're going to have -9 here and -13 goes here. Okay, not immediately obvious what's gone on there, but that's what you do. So maintain the leading diagonal and then swap a mirror image, if you like, along that diagonal and swap the entries over. Now we've almost finished, so we can conclude by writing step 5, which is the last step, and we're going to state the inverse matrix. So step 5. Okay, so this is for a 3 by 3. A to the -1, which is what we're looking for, is going to be 1 over the determinant of A. So that's going to be 1 over the -189, which we computed right at the beginning. So let's put that in, multiplied by the matrix in step 4. So this is going to be -7, -36, -10, -28, -9, -13, and then 14, -9, and -34. All right. Now you'll also notice as well, there's a lot of negatives in this inverse, and we've got a negative as a scalar at the front in that denominator. So what we can do instead is we can now bring that negative inside the matrix, Okay, and then we can basically just eliminate all that negativity. So a to the negative 1 we can write as 1 over 189. Not nice numbers, I'll admit. 7, 36. So just change the signs of everything. 10, 28, 9, and 13. And then we've got 14. Sorry, negative 14. I was getting carried away then. 9 and 34. Right. So that concludes that step. We've got our inverse matrix a to the negative 1. All right, and just to finish off, we're going to solve this system of equations. So I'm going to restate the problem. Remember that we had the matrix A, which I'm not going to write out again, multiplied by the column vector x, y, z. Okay, that's going to be equal to another column vector, 21, negative 16, and 24, like that. Now, as we saw in one of the previous examples, if I want to solve this matrix equation and I'm using an inverse matrix, what I need to do is create the identity matrix on both sides. So that's what I'm going to do. I'm going to just move a bit of space over for this. And if I multiply on the left-hand side of both sides of this equation by a to the negative 1, that's the inverse matrix, which I have preserved up in this top right-hand corner. This product here of the two matrices is going to give us the identity matrix. Okay, so this is nothing more than the identity matrix for 3 by 3. Sometimes we call it I with a subscript 3. So what I need to do now is I need to compute the product of a to the minus 1 multiplied by this column vector here. So that's what we're going to do next. And what we'll get in each of those rows is going to be a value for x, y, and z. So let's do this. So x, y, and z. So let's just state it, x, y, and z as a column vector or a 3 by 1 matrix is going to be the inverse matrix, which is 1 over 189. And I'm just going to write it out. So 7, 36, and 10, 28, 9, and 13. Not nice numbers, I'll admit. It's not going to get much better. Minus 49 and 34. And we're multiplying that by our column vector, which is 21, negative 16, and 24. Okay, so we apply matrix multiplication now. So I've got the first row and the first and only column. I have to find the product of those. So we're going to compute that, and then it's going to be 1 over 189 multiplied by all that. All right, so this is going to give us a 3 by 1 column vector. Now, so we have 7 multiplied by 21, plus 36 multiplied by negative 16, plus 10 multiplied by 24. If we find that, we're going to get the answer, which is negative 189. Isn't that nice? All right, let's move on to the next row. So let's just drag this highlighted part down. We're going to compute 28 multiplied by 21 plus 9 multiplied by negative 16 plus 13 multiplied by 24. That's going to give us 756. Please check this if you're not convinced. Okay, and then finally in the third row, again, we've got some big numbers. Once we compute that using matrix multiplication, we will get 378. Okay, all this is equal to our x, y, and z. So x corresponds to the first entry, y the second entry, and z the third entry. All right, so let's divide everything by 189. So this is going to be negative 1. 756 divided by 189 is 4, and 378, that's going to give us 2. Okay, so after all that work, we can now state our solutions. So we have x is equal to -1, y is equal to 4, and z is equal to 2, simply because they correspond here. So x is that entry, y is that entry. They have to be the same because they are equal to each other. All right, and that concludes that example.